The 10th anomaly, the possibility of structured limitation. When all these anomalies are considered together, delayed observation, universal silence, quantum non-locality, and relativistic constraints, a pattern begins to emerge. The universe appears structured in such a way that information is always limited, delayed, and filtered. No observer can access total reality. Every perspective is partial, bounded by light speed and distance. This raises a speculative but unavoidable question. Is this limitation accidental or structural? Some interpretations suggest it is a natural consequence of physics. Others consider whether reality operates like a system with enforced boundaries, ensuring that no single point can perceive the whole. In such a framework, the light year becomes more than a measurement. It becomes a principle of separation, embedded into the architecture of existence itself.
The 9th anomaly, the illusion of cosmic scale. As we map the universe, we assign meaning to distances measured in light years, but scale itself may be deceptive. The observable universe is limited not by physical boundaries, but by the time light has had to reach us. Beyond that horizon lies an unknowable region, not necessarily empty, but inaccessible. This creates a subtle illusion. We may mistake the observable universe for the entire universe, yet it is only the portion that has had time to communicate with us. If the universe is far larger than what we can observe, then every measurement we make is inherently partial. The light year defines not just distance, but the edge of comprehension.
The 8th anomaly, quantum strangeness over distance. At quantum scales, entanglement challenges the classical meaning of distance entirely. Particles separated by vast distances, potentially across light years, can exhibit correlated behavior instantly. This does not transmit usable information faster than light, yet it reveals that separation may not be as fundamental as it appears. If two particles remain linked across cosmic distances, then space itself may not fully describe their relationship. Instead, the universe may contain non-local structures that persist regardless of separation. This creates a tension between relativity and quantum mechanics, one governed by strict light speed limits, the other hinting at connections that ignore distance altogether. The light year, then, may describe motion through space, but not necessarily the deeper structure underlying reality.
The 7th anomaly, the great silence beyond distance. Beyond a certain scale, signals from the universe thin into silence. Despite the vast number of stars and potentially habitable worlds, we detect no clear evidence of widespread intelligence. This absence becomes more striking the farther we look. Across millions and billions of light years, the universe remains quiet. This is often framed as the Fermi paradox. If intelligent life is common, why is the cosmos silent? One interpretation suggests intelligence is rare. Another proposes civilizations self-destruct before spreading widely. But there is also a more unsettling possibility, that intelligence exists but is separated by distances so vast that communication is effectively impossible within cosmic timescales. The light year, in this sense, becomes a barrier not just of space, but of contact. Even if intelligence is abundant, the delay imposed by distance may render interaction practically non-existent. The silence may not indicate absence. It may indicate isolation on a scale we are only beginning to understand.
The 6th anomaly, cosmic history written in delayed light. Looking deeper into space is equivalent to looking back in time. A galaxy a billion light years away is seen as it was a billion years ago. Entire epochs of cosmic evolution are visible simultaneously, layered across distance. This creates a strange effect.
The universe is not experienced as a present structure, but as a stacked historical archive. However, this also introduces ambiguity. We can never observe cosmic evolution continuously. We see fragments, snapshots separated by vast temporal gaps. The reconstruction of cosmic history becomes an interpretive act, not a direct observation. Models fill in the missing intervals, but those intervals are never truly observed. This raises a question that science continues to grapple with. Are we reconstructing history accurately, or are we filling in gaps with assumptions that feel coherent but remain unverified? The light year ensures that the universe is always partially incomplete in its presentation.
The fifth anomaly, the light that never fully represents its source. Light is our primary messenger from the cosmos, but it is also an incomplete one. Every photon we receive carries only partial information about its origin. It encodes energy, wavelength, direction, but not the full complexity of the event that produced it. A light year therefore becomes a journey of reduction. As light travels across space, it does not preserve reality in full fidelity. It filters, disperses, and shifts under gravitational and quantum influences. By the time it reaches us, what remains is not the source itself, but a transformed echo of it. This raises a subtle but profound question. If all cosmic knowledge is derived from such filtered signals, how much of reality are we actually missing? The universe we construct is not the universe as it is, but as it can be reconstructed from degraded information traveling across immense distances.
The fourth anomaly, time dilation and the fractured now. Within a single light year, relativity begins to distort our intuitive understanding of time. High-speed motion or strong gravitational fields can stretch or compress temporal experience. Two events separated by identical distances may occur in vastly different temporal frames depending on their conditions. This means that a light year is not a fixed slice of time-space. It is a variable experience depending on the observer. The year in light year is deceptively simple. It hides complexity in how time behaves under different conditions. In extreme environments near black holes or relativistic jets, time itself becomes elastic. A journey of one light year might represent dramatically different subjective durations depending on perspective. The implication is unsettling. Distance does not guarantee temporal equivalence. Reality fractures into layered experiences, each governed by its own rhythm. What we call the universe may be less a unified structure and more a collection of overlapping temporal interpretations.
The third anomaly, the empty vastness between signals. As we extend our gaze outward, a disturbing pattern emerges. Space is overwhelmingly empty. Between meaningful signals, stars, galaxies, clusters, there is mostly silence. A light year, in this context, is not filled with information, but with absence. Light travels through vast regions that contain almost nothing, yet those empty stretches define how long information takes to reach us. This emptiness raises a question that resists easy dismissal. Why is the universe so efficient at being empty? Matter exists in clusters, but the distances between them dominate everything. Some models suggest this structure emerged naturally from gravitational evolution after the Big Bang. Others consider whether this distribution is a statistical inevitability. But there is also a more unsettling possibility, that emptiness is not incidental, but essential. If the universe were densely packed, absorption would be immediate and chaotic. Instead, it is structured.
The second anomaly, the limit that defines everything. The speed of light is often described as a limit, but within that limit lies something more unsettling: definition itself. A light year exists because nothing can exceed the speed at which light travels in a vacuum. This boundary determines not only how we measure distance, but how causality itself behaves. Every interaction in the universe is constrained by this rule. Information cannot outrun light. Causes cannot leap ahead of their effects. The structure of reality is, in a sense, paced by this cosmic speed limit. Yet the deeper question remains unresolved. Why this limit at all? Why should information have a maximum speed? Physics describes it, measures it, builds upon it, but does not explain why it exists in this precise form. Some interpretations suggest space-time itself enforces this constraint, like a computational rule. Others propose it may reflect deeper symmetries in the fabric of reality. In more speculative frameworks, the speed of light resembles a processing ceiling, an upper bound of a system that cannot update faster than its own architecture allows. If so, the light year is not just a measure of distance, but a symptom of underlying design constraints we do not yet understand.
The first anomaly, the distant present that never arrives. At the most fundamental level, a light year introduces a paradox that reshapes our sense of now. Every observation beyond our immediate surroundings is delayed. A star 10 light years away exists in a state we cannot currently verify. Its present moment is forever inaccessible. This creates a universe where simultaneity dissolves. Two observers separated by distance do not share the same present reality. In cosmology, this is not merely philosophical, it is structural. The universe does not provide a universal now. The implication is subtle but profound. Reality, as experienced, is always outdated. The farther we look, the deeper we fall into cosmic memory rather than cosmic truth. What we interpret as the universe may be a continuously lagging reconstruction, stitched together by light that refuses to arrive on time. And if the present is always out of reach, one must wonder, does the present exist in any meaningful way at all?